I'll talk about DevSecOps trends, how we define trends in application security. We are focused solely on application security. So I'll talk about trends in the application security industry. And to start with, it's a developer community, and there is a common statement that security is a non-functional requirement. This is something that I hear often from developers, from this is a it's a false statement that leads to a situation like this. If we are looking at, for example, you want to program a shopping cart, okay? And if you want to program a shopping cart, you always look at the functional requirement is calculation of the dollars. But what happens about the credit card itself that is put into the system? Do you put the same attention to protecting the credit card so they will not be compromised? This is as functional as calculating the right dollars, because if the credit card will be stolen, then your business then you can go out of business. So I think that the main message around here is developers, you need to take responsibility for security. It's not something that the security team can do. It's not something that the AppSec team can do. It's something that the developer should do. And this is the main statement of CheckMark, and we're trying to build tools to understand security. Now, if we are looking at the world of delivery of development is changing rapidly in the last 10 years. You look at Facebook, or they are doing about 50 to 60,000 builds a day. Amazon is deploying every 11 seconds into production, a new function into production. It's being done in a speed of light. Yet, 70% of the developers in the world are not properly trained in application security, while 60% of successful attacks start by vulnerabilities that happens in the app level, okay? It doesn't say that the hack is fully done via the app level, but the vulnerability in the app level is enabling hackers to penetrate the systems. And in this speed of development, developers should be aware of security, and we should build tools that can deal with protection and hardening of the system in the speed of DevOps. If we're looking just in April 15th, Santander Belgian block, it's a branch of Santander, the big Santander bank. The Belgian branch had a blog, and the blog was compromised due to misconfiguration. Misconfiguration, not even a coding issue, it's a configuration issue. What happens is that you say, okay, the blog was compromised. What can happen? But once the blog was compromised, the emails of the customers of the bank could be exposed. And this is a great list for potential phishing. If you think about people that are doing phishing in mass scale, they're trying to target their phishing. So they will send you emails that are related to the fact that they know that you are a customer of the bank, and they might catch you with a big fraud. And that's a session, a topic for another session, but these things are happening all the time. So if you think about configuration, it's not even what you code, it's how you configure the system, and this problem can lead to bigger problems. So in hacking, it's a very complex world. So something here can lead to another, and hackers are very sophisticated. They catch vulnerability and they go through the chain and compromise your system. So CheckMark has about 1,400 customers. We have a lot of Fortune 100 large customers in Europe, in US. We are a Gartner Magic Quadrant leader. We have about 650 employees worldwide. And we are deployed in about 70 countries. We have three competencies. One, we understand application security for DevOps. The second, we know secure coding practices, and we have a great team of security experts that enable us to power the tools with the latest and greatest. So some of the things that we found in the last 2 years, for example, we found in Google, in Android, that affected compromise that affected hitchhiking, or you could hike, take control on the camera through an API. And when we delivered the message to Google and to Samsung, they had to fix about 300 million phones to fix the problem. We were able to take the Amazon Alexa and make it an Echo device. And we also went to more, and we were able also to compromise Tinder, but they didn't fix the problem. They had other issues on their end. But both Amazon and Google recognized us as delivering something that was very valuable for them. And we even got money from the bug bounty program of Google. Anyway, I would like to talk about development and how development trends are leading to application security practices. So if you're familiar with the hype cycle, how do I know which trends will materialize? Very few trends in technology are materializing. And the biggest thing about finding the right trends in the industry is to understand which technology trends would materialize, how that's related to development and security. We'll talk about this. So our hypothesis is saying that advances in development create new attack surface, which in turn created advances in AppSec. And this means that things that happen in application development starts here, and then they lead to new themes in application security. For example, we have AWS. So when you look at AWS, they give services like memory services. Then you find leaks into S3 buckets. APIs are spreading, mushrooming around. Then there are API security issues. Service-oriented environment, so code sharing services, then you find vulnerabilities in code sharing services. So each new paradigm in development is leading to new attack surface, and hackers are finding very quickly what are these vulnerabilities in this new attack surface. So the best way to predict the future is really to create it. And how we do it, we look at advances in development. In the past, for example, web application development started in '96, pen testing started in '99, code security started in 2003. CheckMark was founded in 2006, doing exactly that. Infrastructure as a code started in 2007. Then protection of the code started about 2010, companies like Dom9. But nobody till today is looking at the infrastructure, the code itself of the infrastructure to find vulnerabilities there. Same with container security, with Dockers. There are companies like Twistlock and Aqua Security that are doing container runtime security. Till today, nobody is looking in the inside of the code of the container to protect it. And microservices came in 2013. API security protection came in 2017, first companies. Till today, nobody is looking really at the API security protocols and source. CheckMark has just published end of 2019 with OWASP organization, the OWASP top 10 for API security. There is a list. You can look at these publications. So if we are looking at this hypothesis, let's look at, for example, and the phenomena of open source, of the open source. Open source has a long history. People used to share sources in close communities in the 80s. Then Linux emergence in the 90s gained popularity, but not in a corporate play. It started by Red Hat and other companies that build business models around open source security, and Red Hat took Linux and made it mainstream. In the last decade, open source is being used as like mushrooms in 96% of the apps, and the latest I think is even higher, that it consists about 60% of the code base is really components of open source. So when you're coding, you're really taking services from multiple places. You take components from multiple places and you assemble your application. Now, what you do is that when you assemble your application, you take all these open source components, and while you take them, you take with them all the vulnerabilities. So if you are using a very popular open source component, like Apache, hundreds and millions are using Apache. If the vulnerability is found in Apache, a new vulnerability, it's immediately affecting millions of users, millions of applications. So what you see here is the graph of found vulnerabilities, or CVEs, within open source. You see that there is a huge hike starting in 2016. Till then, there were about 6,000 CVEs. Now it came to about more than 16,000 published CVEs in national databases. That's a huge jump in about 2 to 3 years, and it created a huge attack surface around the world because a lot of people are using it, and one component is affecting, it's like an epidemic, it's affecting tons of applications. So, for example, here, open source was used, there were tools that were using compliance on open source to see if you are not compromising licensing, if you are using the proper licensing, and so on. Only in 2013, Black Duck, that was the leader there in compliance, decided that there is a risk. And they switched from compliant to risk. The market size was nothing in 2015, like 30 million, and then it exploded. There was an Equifax breach, and everybody saw that Equifax knew about the problem, couldn't patch it, and then the market really exploded. Tools now are selling in about, from 2015 to 2019, about 10-fold the market size that was created. And CheckMark, beside the fact that we are doing static code analysis, extended the portfolio also to open source analysis. So what are the development trends that we see today that will predict the AppSec future? I think the most important thing is that we can see is that everything is codified today. If in the past you're doing your application code and then you use components, you deployed on servers, you use databases and so on, the application was what you coded. Now we spoke about the fact that you are coding part of the application, then you put open source components, but also if you're coding into a cloud-based environment, then you really don't have an IT. You're using services all over the place. You're using services for memory, for infrastructure, Lambda services. You're creating pipes with code. You're doing change management with code. You have all your environments, virtualized environment. Everything is managed as code, okay? So infrastructure is becoming code. Everything is code. And all this code is sitting in the Git of the world. Git became the source of tools, really. And if in the past you had all the things on the right-hand side, physical things. Today, everything is really services. And if you want to check the level of security within your application and environment, you need to go to Git and look at all the components within Git to see if security, what is the security posture of your environment. Application security, open source security, infrastructure security, and so on and so forth. The other trend that we see, and that's a huge trend, is the fact that developers are the new security owners. And why is that? IT and applications are really merging together into development. If you're looking at the modernized cloud native development group, they're doing everything. They're doing the IT, they're doing the application, they're doing the security, they're doing everything. It's not like in the past that developers and IT were two different groups. Today, it's becoming one group. Okay? So from functional teams, we are going to developer autonomy. With developer autonomy comes the responsibility of the developers to take care of everything, of quality, functionality, maintainability, security, and so on and so forth. They own everything, and the responsibility and everything will go to the developers, but they need to understand it. They need to realize it, and they need to take ownership of that. And since everything is codified and software is everywhere, I would argue that security is everything and everywhere. And security equals software equals security. Security must be embedded within the development processes. It should be a second nature of the developer. And what CheckMark is doing for that, we have a suite of products, the security platform, static analysis. Static analysis is used to find vulnerabilities in the code that you are developing. OSA is finding vulnerabilities in open source component that you are merging into your code. Code bashing is an application security training product, so you will be aware and understand security. And IAST is an interactive application security testing that helps you find vulnerabilities in runtime. All of this is running and integrated within the SDLC environment. We have a lot of integration points, and it is one platform. The most important thing is that if you're looking at a DevSecOps environment or a DevOps environment, we have integrations. You can start scanning from the IDE. You can start doing it from the repos. You can do it from the code management platform like the GitHub, the GitLabs. You can do it on any pull request, on any check-in into the repositories, and you can do it during build via Jenkins and so on. And you can take all the results of the vulnerabilities and store them in Jira, the way you prefer to consume all the bugs that you find in the system. And I would argue that since software equals security, that you need to treat security bugs the same way that you are treating any bug that you find in the system. Prioritize them correctly, but you need to fix them at the time of development, because more time that it takes you to fix a problem, the more expensive it is to fix the vulnerability. And we say shift left, okay? Start from the beginning. Start from the moment that you are thinking about the code, think with security in mind. And then immediately thereafter, test yourself. Have it as a second habit in your programming habits and methodology. With that, I would like to, unless you have questions, I would like to move to Julian for a demo.
Yeah, I think if anyone has any questions, please you can use the chat now. Just a few questions in there, or you're also welcome to unmute yourself and ask a question to Moshe regarding the presentation. Doesn't seem like. If any question pops up, you can just throw it in the chat and we can take it in the answer it in the end. So otherwise, Julian, you are welcome to.
Yeah, hi everyone. So let me share my screen and start doing this. Okay, hopefully you can see my screen. So I'm Julien Bruno. I am a sales engineer working for more than 18 months at CheckMark. And before that, for more than 10 years, I've been working around QA and DevOps. So it was very thrilling when I joined CheckMark and seeing all the integration points that CheckMark provides into the CI/CD pipeline and all the DevOps lifecycle. So as previously, if you have any questions, feel free to interrupt me, put them in the chat, and we can take them ad hoc. Okay, so what I wanted to talk to you today about is about an automation framework that CheckMark has raised recently, which is called CXFlow, and that will really help you understand how we can help this shift for testing for security vulnerabilities as early as possible into the development lifecycle. And I'm going to support that with a demo as well. So let's move on. So what is this automation framework? What is this goal? So obviously, when you speak about automation, you don't want to make things more complex, right? So CXFlow is a good way to simplify this. First, CXFlow will be able to let you reduce the DevOps friction, okay? Because I mean, if you are working in a big company, you have hundreds of applications which are normally usually included into your SDLC lifecycle, who have their own pipelines. And so perhaps if you go and see your DevOps team today and tell them, hey, you have to modify my 500 pipelines in order to add a step to scan for security vulnerabilities, well, they may not be too happy about it. So that's why CXFlow is a dedicated framework that can work standalone or that can be integrated into the SDLC itself. Then also it helps us to ramp up your application security testing automation by providing actionable results. So, and by actionable results, what we mean is that first, the results will be easy to prioritize, and not last but not least, they will be available directly into the developer's working environment. So we don't want developers to be disturbed. As developers, we already have lots of different tools to use. So when somebody asks us to do security and we want to start doing security, we just don't want to have to switch to yet another system. We want it to be as seamlessly integrated as possible into our existing applicative ecosystem. So it could be GitHub, could be Jira, could be Jenkins, could be whatever tools you are used to already. And so obviously this automation frameworks provide not only support for the static code analysis, but also for the software composition analysis, meaning the open source library, right? So next, CXFlow can be implemented in different ways, as I was mentioning earlier. So whether you can do, you can do multiple event-based scanning. So you have different ways to approach that, whether you want to have CXFlow running as a standalone web server. It will expose a web service, and you can configure then your repositories via webhooks to push events to this web server that will trigger a scan and the creation of the tickets. Or you can also have it integrated into your existing pipeline as a batch, very simply. So just technically speaking, it's just a jar file. So you can run it as a jar file, or you can also run it inside a Docker image. I will provide details at the end of the presentation where you have more information where you can find it. I forgot to mention it's an open source project as well. So in terms of actionable results management, what's great is that, as developers, we have to manage our tickets on a day-to-day basis. But guess what? If you fix a vulnerability into into your code, and then you run a SAST scan. Then with SigFlow will pick up the result. SigFlow will understand that from the previous scan, you have been fixing this specific vulnerability, and automatically SigFlow will close or change the ticket status to the one that you have configured to, without you to have to do anything about it. It's completely automated. So of course, we can integrate with ticketing systems. So it could be Jira, could be GitHub issues, could be Azure DevOps work items, could be GitLab issues as well. But we can also give back some feedback directly into the collaboration tool, into the SCM itself. So meaning that, for instance, in GitHub, not only will we be able to update the issues, but when you do a pull request, meaning when you have made some changes on your development branch and you want to push them to your master branch, you then do a pull request, and then you will be able to fire an event that will be called by SigFlow, triggering the whole workflow and a scan, and the feedback, meaning the results of the scan, will be fed directly back into the pull request comment. So that when you have to approve to the pull request, you will have the scan results straight away into the pull request details into GitHub. And that's what I'm going to show you later on. All right, so of course, the last point is about centralized management of the policies. So you can decide when you want to open tickets. Of course, you can map that to your custom workflows. So some of you may be using Jira, for example. So you know Jira is highly customizable in terms of workflow. So you can obviously adapt the configuration of SigFlow in order to do that. But you can also have some different policies where you may want to break a build, or you may want to prevent a pull request from being fulfilled. So all this can be configured very easily in SigFlow. Before I move on, any questions? Okay, so now let's imagine the day of a developer. These are here. So Moshe earlier was saying that it's easier and better to identify security vulnerabilities as early as possible into the development lifecycle. And so that's what we are going to demonstrate here, so you can grasp better this idea. So of course, Lisa is coding away on our local branch. She has been asked to code a feature or to fix something, right? Then when she's happy with her changes, she pushes her development branch to her repository, to her LTS system. And then she will request the approval via a pull request in order to merge her changes into the master. So at this point, the code is approved and is merged into the master branch. Then at the build time, and this time we are not using SigFlow yet, at this time during the build phase, a scan will happen. So a SAST scan, an open source scan will happen, but let's say a SAST scan. And then, boom, after the build is done, Lisa receives 3 critical security bug tickets. But the issue here is that they are already merged into the master branch. So it would have been obviously better if we have been aware of these vulnerabilities beforehand, so that we could have remediated to this before merging into the master, right? And this is exactly the idea behind SigFlow and leveraging the webhooks. So now with SigFlow, it's the same workflow here. So she starts coding in a local branch, she pushes it, then she requests a merge to the master, but then SigFlow comes into action, and Lisa is provided directly with the security vulnerabilities, and then she can fix them and then resubmit another pull request to ensure that she merges into the master without any security vulnerabilities. Right, so now that we know how to make Lisa happy, I'm going to show it live with a demo. So just a little, a few words about my environment. So here I'm going to demonstrate 2 use cases for SigFlow. So the first one is here, I will be simulating a CI server. So I already had done some scans on my environment. So I will launch SigFlow in order to pull the scan results with a batch in the same way that the CI server would have done. And I'm going to go and populate the Jira project with the security vulnerabilities found. And then what I'm going to do, I'm going to simulate, to put my developer hat on, and I'm going to go and consult my Jira tickets. And obviously, I'm going to try and make some changes. So we'll talk about remediation, how CheckMark can help identify the vulnerabilities and learn how to fix them, obviously. And then we're going to work on our local branch to do a quick fix or simulate a quick fix, push our dev branch to GitHub. And then from GitHub, we're going to trigger a pull request, of course. And at this pull request time, you will see that the Sixflow, which I have also running as a standalone on my machine, will be catching the event configured through the webhook in GitHub, and then we'll trigger a scan in CheckMark, and the vulnerabilities found will come back in feedback of the pull request. Okay, I just put it with some words as well to make it more simple, because I know it's understandable. So the demo flow, Jira tickets backlog generated by the CI scan. Then I take the vulnerability. I'm going to do the analysis from my IDE with the CheckMark plugin. I'm going to fix the vulnerability on my development branch, push it back and push it to GitHub when I'm satisfied. Then initiate the pull request from GitHub and look at the scan feedback in the pull request command. Okay, let's do it. So just before we jump into that, I want to show you the configuration of my flow here, just for the batch that is going to retrieve my Jira ticket. So as you can see, it's configuration as code, right? So we have all the details of our CheckMark environment. We can do some filtering, obviously. So if I wanted to focus only on special severities of results, so let's say my project I'm working on is not very critical. I only want to be aware of the high critical severities, vulnerabilities, sorry. So I can filter, can set this filter to tell Sixflow to take care only about the very critical ones here. Then I can filter on the category. So for this demo, I'm using Bodge IT, which is vulnerable and contains a lot of vulnerabilities. So I have reduced the scope to these three types of vulnerabilities: SQL injection, stored XSS, and reflected XSS. But we have also different ways to filter that. Then I have to provide with my CheckMark details, obviously, and then my Jira connection details. Then you can see that's where we are doing all the mapping of the fields, obviously, with Jira tickets and the CheckMark results. And we can set up the statuses we want to update our ticket to along the way. So now I see the question coming. This is good. So this is for one project. All right, but I have 200 projects. How is it scalable? Well, there is a solution for that as well, is that Sixflow supports configuration as code, as you can see here. And so we can provide a general configuration for Sixflow, and then you can override the properties. These properties can be overridden for each and every project via a properties file that would look exactly like a JSON file, not a YAML file in this case, that you put directly into your repository along with your code. Meaning that when Sixflow will be triggered, it will check the repository, it will see this configuration override file is present, and it will be able to override the specific parameters for this specific project. Okay. So let's move on. I'm going to show you the log. This one. Sorry, I don't know if it's too small or not. So as you can see, the way it's being executed here in this case, it's just a simple jar file. So I just call it and I pass it my Jira YML file, configuration file I just showed you with a few arguments. So here I'm telling it the project mode. So I want to just get the results from CheckMark, send them into Jira, and I give just the connection details there. So as you can see, what happened when I executed it earlier today, I was able to retrieve the scan status of this specific project. I found it into CheckMark, and then I process the results. Sixflow process the results for me and put them into Jira. And then, since I already did that for this project earlier, it updated all the already existing Jira issues. So how does it look like into Jira? There we go. This is my project. I have some open issues. Ta-da. I have some open issues. There we are. Sorry for loading time. Let's take this one. Yeah, okay, so let's take this one. This one is, I think, a simple one. It's a stored XSS vulnerability in the contact page. So usually, you know, in this contact page, that's where you would be able to put your name, put a comment, and send it. And or it could be even displayed then afterwards in an admin interface and so on. So obviously, if you don't sanitize properly the data you are getting from the database, at some point it may cause an XSS vulnerability. And that's exactly what CheckMark told me here, that Sixo told me here in my Jira ticket, is that we are getting some data from the database and it's flowing through the code without being properly filtered or encoded. And so it's eventually displayed to the admin user in the end, in a page, and then that may consist into a stored XSS. So let's imagine that our AppSec team has been working on this, has been triaging these results already. It's been identified and confirmed, so I have to fix it. I'm the developer. I got my liter of coffee in the morning, and I start taking my backlog of issues. So when I get in front of my my Jira, I see this ticket. I'm going to handle it. So how do I handle it? You can see here we have a link, and this link will take me directly to the CheckMark result. I don't have necessarily to do that in order to fix. I don't have to go to CheckMark necessarily. I just wanted to show you how the interface looks like. If I just can find my other, there it is. So this is how the result looks like in CheckMark. So as you can see here, we have all the different results broken down by severity and by language. And I have one result selected here, which is my stored XSS initiating in the contact JSP page. So it's a confirmed result, so I know I have to fix it. So now what is great about CheckMark that will greatly enable me to fix this is to see the attack vector, meaning I can see how the data flows through my code. See here, I mean, it's fairly straightforward in this example there, obviously. We are selecting star from comments, and then we are browsing through the results and displaying it straight away, concatenating it into a table. So you can very easily understand that if this database input is not sanitized properly, then it may easily make a stored XSS. So in this case, it's very simple. And the attack vector that I can see here is a very simple one because everything is in one place. But if I take a more complex, result, let's take another one, like login, for example, or this one, or this one. Yeah, you see this one is a bit longer and may flow through different files. So with this attack vector, I really can see the complete data flow and the complete vulnerability, and it makes it very much easier for me as a developer to understand it better and to see where I have to fix. Now, another great feature about CheckMark is that CheckMark will also show me what we call the best fix location. As we are able to calculate all these data flows, we can also tell the developer, which are the data flows that intersect together in order to show them where may be the best way to fix something. So I can see here, I have different flows all originating from the same here. Let's have a look at it. Okay. So this one looks like, yeah, I'm in login JSP, and I'm getting a username and a password, feeding them into a session, and then I may be using them afterwards in different scenarios. You see, all this beforehand is starting from the get attribute from the session, and then we have different data flows. At some point, it's even displayed directly into the user. So obviously, if all that is not sanitized properly, that may also consist in some stored XSS, right? But let's get back to our developer. I'm the developer. As a developer, I don't want to work into the CheckMark interface. I want to work from my IDE, obviously. So let's close this. That's for later. Let me switch to my IntelliJ. So in my IntelliJ, I have opened my project, and with the CheckMarks plugin, I have retrieved the results for this project that I scanned already. So which is great here is that you can see it's really the same interface as you could see in the CheckMarks website, right? So we also have the same list of stored XSS. If I look at my contacts here, that's the very same. I can also see the data flow there, get tag vector. I can flow through the code. I also have access to the best fix location and to the graph view. So that even enables me, as a developer to fix at once several vulnerabilities. So meaning that if I put some sanitation just after getting these usernames here and passwords from the database, then that can fix at once all these potential stored XSS which are depending on this same input, right? So let's just do that. I'm going to simulate a fix. So here in this case, as you can see, if we go back on our context example, we are getting all the comments in there. And what happened then? We are creating a table and we are concatenating straight away name and the comment. So we want to sanitize that. So let's imagine that as a good developer, I have created my own sanitizers. I may have a custom sanitizing method that I can call from there. So here it's a string. If I override the string, obviously, if I extend the strings, I could do that. Sanitize XSS with a small letter would be better. Obviously, it's just an example here, so I didn't code that. And that's done. So basically, that's all I have to do in order to make it happy and to remove the stored XSS vulnerability. So now it also means that CheckMarks must be aware of my sanitizer, and you can configure CheckMarks, the scan engine. You can customize it in order to recognize this sanitizer and not to identify it further as a vulnerability. So now that I'm happy with that, I'm going to save it. I'm working here on a local development branch. You see here the security fix branch. So what I'm going to do now, I'm going to commit this and to push it. Sanitize contact page. So I'm going to commit. Oh, I forgot to push. I'm pushing it. It is running there. All right, so now let's see what happens in CheckMark. So first in GitHub. You can see I have two branches, and you see, yeah, my security fix received a push. And so now obviously I can make a pull request. All right, so before we jump into the pull request, before I generate the pull request itself, let me just show you quickly the configuration on the GitHub side, because it will be very quick then to show you the results. How shall we do that? I will first generate the pull request, then I will show you the settings while the scan is being executed. So now I'm happy to push my code into the master branch. So I'm generating a new pull request, create pull request. Yeah, you see there are some pending checks now. We can see that it's pending a CheckMark scan and that the CheckMark scan has been initiated. So if we look behind the scenes on the CXflow server itself what has happened in the meantime. That's here. That should be happening at 15:47 here. Yeah, so there was a push event on the security 6 branch, which was not treated because we only look at the master in our case. And then we have processed the GitHub pull request. So what we can see, what happened is that the CXflow web service, which is running on my machine, has been catching it. So it's connected to the CheckMark server and has created a scan, initiated a scan. So that should be an incremental scan. It should be fairly quick. I'm using a multi-tenant environment though, so yeah, there it is. Here is my scan. It's running. Okay, so while this is running, I wanted to show you how I configured my GitHub repository with the webhooks. It's very simple. You have no payload basically. You just send the application JSON payload to your endpoint. In my case, it's running on my local ngrok instance, which is proxying into my CXflow web service. And then you select the pull and the pushes that you want the webhook to deal with, and you just save it. That's all you have to do. And obviously, you have to generate an authentication token from your profile. Great, let's get back to it. Let's look at the pull request. It's not done yet. Yeah, okay. So the scan is finished. You can see that CXflow code that the scan was finished. It's retrieving now the reports, meaning the results from the scan. And now we are going to update automatically, obviously, the pull request command. You can see here, that's been done. So in my case, I didn't configure it to prevent the merge. So the status is still green for the pull request, but we could, of course, change it and prevent the merge itself. Because obviously you can see we still have lots of different vulnerabilities in our code here. So obviously this is not good for approving the pull request. So the pull request approver will be able to see that and send it back to the developer, or the developer could take action by himself in order to do that. That concludes my demo. I just have a couple of slides just to summarize, and then we can have a more detailed Q&A session if we have 5 minutes left. Yeah, so just wanted to take you through a few takeaways about CXflow. So first of all, as you can see, what's in it for the developer, apart from making him happy, as you see here. So it helps you really catch and fix vulnerabilities during the coding phase at early stages, right? And it's for the developer, it's work as usual, meaning that there are no disruptions, very few new tools. I mean, during this demo, I was still working in my work as usual development environment. I was using Jira, I was using GitHub, I was using my IDE. If I didn't want to go into CheckMark, that's fine. I have all the information I need straight away from my IDE. And obviously, I didn't have to open the tickets myself, or I wouldn't have to close them myself because CXflow is doing that for me. Now, from an organization standpoint, obviously CXflow simplifies the application security testing lifecycle, because it provides automation, and therefore it provides also efficiency by reducing the friction between the development and the DevOps, because you don't need to change drastically all your existing CI pipelines. You can integrate nicely as a standalone web service standing next to it, and which overall drives the total cost of ownership reduction because you will have to maintain less CI plugins. Last but not least, where can you get more information about CXflow? Because I'm sure that all of you are already looking forward to using it, right? So CXflow is an open source project, by the way. So you have the reference here to this to the CheckMark TS GitHub repository, which hosts the stage flow. And then from there, you can just grab the jar file and start playing along with instructions provided in GitHub, or you can use the Docker image, which is available on Docker Hub. Of course, we also have the IDE, CI, and command line interface plugins for checkmarks, which are available at checkmarks.com/plugins, and you can start playing along with them. So if you need some trial environments of checkmarks, we can discuss about that as well later on. That will be probably more question for Moni. Well, thank you very much for your time.